Another important element of pre-planning is the scene level of detail. We've discussed the level of detail you need in your storyboard. Now we are discussing the actual 3D scene that you will be creating in 3ds Max. It's very important to minimize the density of your scenes. That means the number of objects and the number of polygons. The number of polygons has to deal with the number of faces in a 3D model. The goal is to have the absolute minimum number of faces in an object in order to get a model that meets the quality standards of your client. This will depend on things like the distance from the camera or other things that are happening in the scene that will distract from the detail of the particular object. This is especially true if you're going into the games and simulation industry. Those industries, the number of polygons and the number of faces are extremely important, and is probably the #1 most critical element for that type of production. In many cases, the art director will give you a polygon budget or face budget that you cannot exceed. They may come to you and say, create a building with a face limit of 2,000 faces. On the other hand, you have architects and designers who may say, well, I don't care how many polygons it has. My CAD program can handle any number of polygons. Well, of course it can, and there's a reason for that. Many CAD programs don't use polygons. But that's not something we're interested in for this lesson. Our concern is with 3ds Max. In 3ds Max, the more polygons you have, the more faces you have. The more computer resources you're giving up unnecessarily, and the longer it will take for your scene to render. One aspect of scene level of detail that many people don't take into consideration is the number of objects in a scene. It would be possible to have a scene with 1 million faces and only 5 objects, which renders much faster than a scene with 1 million faces and 10,000 objects. Try to keep the number of objects in your scene to a minimum. Now we look at the storyboard that we're using for this production. We have the exterior scene. We're looking at the street from a far distance, and all we see is the outside of the buildings. So there should be no detail on the inside of those buildings, because we don't see it. Even the buildings themselves don't need to be very high resolution, just simple boxes with minimal modeling to make them look like the buildings they need to be. But there's very little detail you can see from the distance, so we wouldn't require a very high resolution model. Panel number 2 shows the front of one of the buildings as a close-up, with a little more detail of the building itself. But again, it's only a facade, a false front of the building. It's kind of like in real movie making, if all you see is the exterior of the street when you're running down the street. There's no reason to put rooms and furniture in the rooms of the buildings. You can just build some plywood mock-ups of the exterior, dress them up, and run your camera down the street, and you would never know the difference. In the case of this building, there's nothing inside it, and there's nothing around it that will be seen. And you don't need any more objects than what you can see in order to get your point across. Remember, model efficiently, and keep in mind to always minimize the number of polygons and objects, and you'll notice a marked increase in the level of productivity and a decrease in your production time. Let's have a look at a practical example of how minimizing the number of objects in your scene and minimizing the number of polygons in your scene can be a very effective production tool. We're going to open a file from your project directory. Click on the Application button, then click the Open option. You should be in the Scenes directory inside of the Understanding 3D project directory. In the Scenes folder, navigate to Chapter 02 and select the Chapter 02 Level of Detail 01.max file and click Open to open the file. When it loads, you'll see what is a very simple scene, or what appears to be a very simple scene, with 1,000 boxes and 1,000 spheres, each with a high number of polygons. In the perspective view, you can see that I have enabled some statistics. The 7 key is the keyboard shortcut for statistics. It shows that we have about 8.7 million polygons. We have 2,000 objects, which is not shown in the statistics, but that's how many objects there are in the scene. The point of this is that these objects are much higher density than they need to be, and there are a lot of objects not visible in the scene. There are spheres hidden inside of each one of these boxes. We're going to go ahead and render the perspective viewport. Make sure the perspective view is active. There should be a yellow box around the perspective viewport. Move the cursor up to the main toolbar and click the render button on the very right-hand side. Allow the rendering to take place. The speed of the rendering will depend on your computer system, so we don't know how long it's going to take, but it'll be relative no matter which computer you're using. Here we have our rendering of the boxes. It's an array of boxes totaling 1,000 with a sphere inside each one. We cannot see the spheres, they're hidden by boxes, and they're absolutely visually useless information in the scene. This would be very similar to rendering a building with all of the furniture on the inside. If your concern is with the exterior, the furniture is wasted geometry. Close the render dialog. Now we're going to eliminate the spheres. To make it a little easier, there is a selection set already created. A named selection set. Move the cursor to the main toolbar. Click the down arrow on the right-hand side of the named selection set drop-down box. Click on the named selection set called Spheres. This will select all the spheres in the scene. With all the spheres selected, we press the Delete key, which will get rid of all the spheres by deleting them from the scene. Since we can't see them, and they add no visual information to the rendering, there's no reason to keep them. If we look at our statistics again, we now notice that we have 4.8 million polygons, and we're left with only 1,000 objects. So we've eliminated nearly half the polygons and half the objects. Notice down at the bottom left side of the screen is my render time. Your time will be different depending on the computer system you're using. Faster systems will have shorter render times, where slower systems will have longer times. This is the amount of time it took to render this last frame. Remember your render time, or you can write it down. Render the perspective view again by clicking the render button on the right-hand side of the main toolbar. Once 3ds Max is done rendering, we'll compare the render time at the lower left-hand side of the screen. You should notice that it took less time to render than previously. And in some cases, you can knock off nearly a third of the render time for the scene. And does this make very much of a difference? For rendering this one frame, it might not make a tremendous amount of difference, just a few seconds. But if I'm rendering thousands of frames, a few seconds can add up. Or if I have a rendering time of several hours, decreasing that render time by a third can save me a significant amount of time. We did this simply by getting rid of the objects that we don't need. Now let's see if we can get this to render even faster. Go ahead and close the render dialog. In the perspective viewport, go ahead and select one of the boxes. It doesn't matter which one. In the command panel, click on the Modify tab. That'll take us to the Modify panel. If we look in the parameters rollout for the box we've selected, you'll notice that we have the length, width, and height segments set to a value of 20. At this point, it's not important to understand what's going on with these numbers, just that we're going to reduce the number of polygons each box is made of. This can easily be done by right-clicking on the spinner to the right of the number value for each segment option. That will automatically set the value to one segment for each value. Click the render button. By reducing the number of polygons, we've reduced the render time significantly, and the scene looks exactly the same way it did before we reduced the number of polygons. So we have significantly reduced our rendering time without changing the visual quality of our rendered image. This is one of those rules that you always want to follow. Close the render window, and if we look at the statistics, we can see that we're down to just about 12,000 polygons. So we've taken this scene all the way from 8 million polygons down to 12,000 polygons without changing the visual quality. File output is the next issue we will look at in the pre-planning process. This aspect requires a fair amount of thinking ahead and discussion with your client regarding the different aspects of file output. If we're doing print or web-based still images, then we have several options that we need to consider. What is the resolution? What is the size of the image? For printing, it comes down to resolution equals dots per inch. So we need to calculate what is going to look best for the size of the print and the viewing distance of the print. For web, it's simply a resolution in file type. We need to know what file types are most efficient while maintaining our quality. So this needs to be discussed up front so everyone knows what formats the production will need to be outputted. For animations, it's a bit more complex. We need to know the resolution, of course. How big an image can we expect the client to be able to view? Will it be a video or DVD project? Will it be played back off the computer, or will it be streaming from a website? Is the file going to be an AVI or QuickTime file, or is it some other file type, say for a DVD or Blu-ray disc? For animations, we also need to know something about the codec. The codec is what essentially translates the video, which again converts a sequence of images into a single compressed video file that can be played back. An AVI file can have many different codecs. The same goes for a QuickTime file. It's extremely important that this is established up front as part of the pre-planning process.